Hello, everyone, and welcome to Advanced Persistent Threats, How to Protect Your Business Through Multi-Layer Detection. Today, we're going to look at what an APT is, and then review some next-generation defensive technologies to help protect against them. I am Amelia Hugh, the Senior Event Specialist at ESET North America. Please note that this live presentation is being recorded, and it will be available following the conclusion of the webcast. For more information, please check out the Attachments tab in your BrightTalk viewer. There is a link to the ESET blog, welivesecurity.com, as well as some information on the specific products mentioned here today. If you have questions for the presenters during the webcast, please submit them through the question tab also at the top of your screen, and we will address them during the Q&A session. Just a note on questions, they are completely anonymous and we cannot see who you are, so please feel free to send in any and all questions. At this time, I'd like to introduce our presenters today. First on the line is Ari Goretsky. Ari is ESET's distinguished researcher and has been with the company for over 9 years. A 25-year veteran of fighting viruses, today he is responsible for threatscape monitoring, investigations, and working with researchers in and outside of ESET globally. He was the first employee at McAfee and is a veteran of several software and networking startups. He has received industry awards from Microsoft, Lenovo, and Securing Our eCity for his efforts to help make computing safer. Also on the line with us this morning is Don Lewis, our Solutions Marketing Manager for Business Security. He will be covering some of the new detection features of the latest generation of ESET business products introduced earlier this month. Don has been with ESET for 4 years and has worked in high technology and product marketing for over 17 years, specializing in software and security for both startups and established companies. So with that, I'd like to start the presentation and hand it over to Ari. Ari, welcome to the webcast. Thanks for being here this morning.
Good morning. Thank you for allowing me to present today. Amelia, Don, good to be here. To kick things off, I am going to tell you a little bit about ESET for those of you who may not be familiar with us or not as familiar with us as you'd like. ESET is a leading security solution provider for companies, the home. We protect everything from those smallest smartphones to those largest servers. What we are known for as part of our security portfolio is proactive threat detection. That means using technologies like heuristics, generic detection, similarity matrices to protect your computer against threats which, well, may not have appeared before. And we'll talk about that a little bit more. Today, we have a presence in more than 180 countries. And in those 180 countries, we are protecting, well over 100 million users. For the past dozen years, and actually I think it might be closer to 13 now, we've received a record number of Virus Bulletin's VB100 awards, which are the kind of apex of industry awards for detection. And as of 2013, and that's data that was published last year in 2014, I should mention, we're the 5th largest endpoint security vendor. Okay, so now that you know a little bit more about ESET, I'm going to go ahead and tell you about what our agenda is. Today I'm going to discuss advanced persistent threats. It's a term that I don't like. I'll explain why I don't like that. And then we're going to talk about how a determined adversary works, looking at the different phases they go through to use their APT. I'll talk a little bit about some of the techniques and technologies that have been used in advanced persistent threats. And then I will turn things over to my co-presenter, Don, who will talk a little about some of the new next generation security technologies that we can use to protect against these sophisticated threats. And then, of course, some of the solutions that use those technologies to protect you. Okay. And since this is an ARI presentation, I also like to mention what we are not going to talk about, kind of out of bounds for the presentation. I'm not going to go into detail on specific individual APT campaigns. There's a lot of information about that on our We Live Security website. If you have specific questions and there's time, we can get into those. But otherwise, I suggest looking there. Also, this is not a deep dive. I'm here to talk to you about how to defend yourselves against APT campaigns, not write them. That said, it's important to understand the background and the larger context of those, so I'll be talking about that a little bit. Okay. Moving right along, I'd like to just open with, well, what exactly is an APT? It's an initialism, an abbreviation. It's short for Advanced Persistent Threat. And you're probably saying, well, great, what does that mean? Well, I like to break it down with the following somewhat humorous definition. Advanced means that the perpetrator behind that was smarter than you. Okay. Persistent means that they were successful. And threat means it was a risk that you accepted for your organization. And I can't claim credit for that definition. It was developed by Paco at Cigital. But I think it's a good kind of humorous introduction to what's a very serious topic. And so moving right ahead, there really isn't a formal definition of what an APT is. You see a lot of mention of it in the press, both from security companies and from those who've been affected by them. And I think actually the term gets abused a little. There are companies out there who would, not to name names, but they would rather scare you about APTs than educate you as to what they're about and what the risks are there. And then the other half of that is there are companies who've not taken proper security controls. They've not managed the risks properly, and they use that as a kind of get-out-of-jail card. Oh, it was an APT. I'm not particularly fond of those, so I am actually going to ask you to think about this in a different capacity. And instead of thinking of talking about advanced persistent threats, what I'd like you to think about are determined adversaries. Now, a determined adversary is the entity behind the advanced persistent threat. Another way of thinking of that is, the APT might be the bullet in the robber's gun, but the robber is the determined adversary. The APT is merely the tool that they're using. Okay. And with that in mind, I am now going to take you through the 5, as I've identified them, ways that a determined adversary works. I'll point out this is not concrete. It may operate with more or less in different fashion. This isn't an area where we have a lot of visibility. These phases are based largely by my observation of APT campaigns that I've seen from working here at ESET, as well as in discussion with other researchers. So the first step in thinking like a determined adversary is to conduct reconnaissance, figure out who your target is, and once you've done that, you can begin analyzing what you've learned from them to figure out how you're going to attack them. You then conduct research into that attack, developing something that will work to successfully meet their countermeasures. Then after you've done that, you do a little bit of beta testing. I called it a trial run here on the slide. And then finally, you begin the APT campaign. And let's go ahead and take a look at those in more detail. So as I mentioned, the first thing to do is size up your target. You'll begin by conducting some reconnaissance. And you're going to try to identify not just information about the company, but the employees at it. Build a map of people at the organization. Figure out who's there and in what positions. But also look at their network infrastructure, what you can learn about what's public-facing about their company's computers. And once you've done that, also take a look at the specific tools and vendors employed in that process. That may sound like a difficult task. It's usually actually pretty easy to do. And the reason is most of that information is splattered across the internet. On a company website, they'll often have press releases talking about technologies that they might use. Their job descriptions will contain very detailed descriptions of what tools they use, what versions, what they use them for. Social media, employees like to talk about what they do. If it's a technological product they're using, they may be asking questions about it for support on a vendor's support web forum. That's another great way to identify folks who are using technologies. You can also look at organizations, trade associations that the company or employee belongs to. It's a pretty good idea that they might be using technologies. And lastly, network tools, public databases, finding out where they're hosted is a great way of figuring out vulnerabilities. So you would take all of that information, and once you've gathered it, start working on figuring out who you're going to target, and what you're going to target. You're going to be looking for people who might be ideal candidates for spear phishing, weaknesses in their infrastructure that you might be able to exploit, poor controls on domain name registration, things like that. See if they're using old, outdated networking gear, heartbleed anyone. Perhaps because of job descriptions or support website, you know that they're using old web frameworks or security tools that you can begin looking for or developing exploits to. A lot of times organizations have decent level of protection around their perimeter, but once you're inside them, it's kind of a mess. And that's something the determined adversary will definitely exploit. Okay. So after they've conducted that research and identified candidates, you start building the technologies to attack them. There's several ways we believe that you can go through this, ranging from building everything yourself. That might be kind of the approach you want to take if you're a, say, nation state or two who wants to prevent another nation state's nuclear ambitions. You might also work through the hacker black market or gray market to work with zero-day brokers, boutique hacking firms to give you things like 0 days that you can weaponize. You might also partner with related attackers. That is fairly rare, but there are some instances where we have seen that happen. In particular, Chinese hackers tend to work together, sharing information on forums, private forums, towards goals And we've also seen some anecdotal evidence that even nation states work together, and particularly 5 or 6 on various attacks. The problem, though, with partnering up with someone is the more parties you involve, the greater the risk of attribution, simply because eventually one of them is going to have some bad OPSEC, operational security, or a leak. So after you've built your attack, after you've come up with your strategy, you test it. You go ahead and simulate the target as best as you can, and you keep working through that, refining your attack until you have the confidence level that it is going to be successful. At the same time that you're doing this, you might want to simulate some actual attacks against the real company, not necessarily using your own techniques that you're planning for your implant, but just to kind of get a feel for how they respond, and possibly even generate some alert fatigue on their part. If they're seeing a lot of unsuccessful attacks, they may introduce a false sense of confidence. So they feel like they're doing pretty good, and that allows you to slip your novel attack in. At that point, lastly, you begin your implantation of the target with whoever the candidate is, and slowly work your way through compromising computers in the network, in the company. If you're going to do this successfully, you probably have to take some time. You don't immediately start hammering on administrator accounts, domain controllers, things like that. The key here is stealth. You also want to watch for signs that your attack has been detected, and of course, things which you may do to refine your attack campaign, either this one or the next. I will point out, again, these 5 phases are my interpretation based on what I've seen. They may occur in different order. They may occur in parallel. It's kind of hard to say. We don't have a lot of operational data on the actors behind campaigns. This is a bit of speculation. That said, if by any chance you are a determined adversary who is running an advanced persistent campaign threat, please get in touch with me. I'd be interested in speaking to you. Okay. With that in mind, I'm going to turn us back to Amelia, who has a question for you.
Great. So just to kind of get a sense of, who we've got on the line and why you're all kind of here. Our first polling question today: which of the following targeted attacks are you most concerned with? Is it A, a targeted attack through emails, B, through social networks, C, through your company website, D, on company social media profiles, or E, on company cloud services? So we'll give you guys just a few seconds here to respond.
I see those votes are coming in.
Yeah, they're coming on in. And just a note on the voting, we cannot see who you are or how you're answering for these polling questions. Also, for the folks watching on the recorded version, just note that voting is only open during the live presentation. So now is your time to talk to us. Send in your votes, and we'll go over the results in just a few seconds here. Okay, looks like you're still rolling in here, but looking like a lot of you are concerned with attacks through emails, about 50% of you. And then another 40% of you are concerned about attack on company cloud services. Just about 10% of you through social networks. And those are kind of fluctuating
Mhm.
a bit here, but it looks like email, cloud services, and then social networks are kind of leading the way here. Interesting results.
Yeah. Yeah, I have to admit I'm actually not too surprised. Email is one of the oldest services, and it's still one we see a lot of security issues with. Okay, so I think we can move on now if we've gotten enough. Okay,
Yeah.
we're going to go ahead and move on. I think everyone who's voted is going to vote. Thank you for answering that poll. I do appreciate that. So, as I mentioned, I was going to discuss some of the technologies and techniques used by APTs, and just give you a quick overview of those here before we dig into them. A popular mechanism for avoiding detection, maintaining persistence, is the use of rootkit technologies. If the attacker's goal is to steal information or implant information into your network, they're going to be dealing with outside infrastructure. So we can talk about the command and control servers, the exfiltration logic like that. Sophisticated APTs will store their attack code and data in places that are not hard to get at. So we'll talk a bit about some of those custom locations. I'll also take a look at some of the evasion techniques they use to avoid detection. We'll talk a little bit about firmware implants, and then I just wanted to mention some of the programming languages and file formats we've seen. So with that in mind, let's go ahead and move forward and talk about rootkits. Rootkits are not actually anything new. The technology actually predates the personal computer, dating back to many computers, time-sharing systems. What is a rootkit? Well, there are a lot of definitions, but simply put, it's a tool used to allow an attacker to bypass your existing security mechanisms and maintain access to a computer system. In order to perform that functionality, rootkit typically has to start as early as possible, initializing while the operating system itself is loaded and running from a privileged context, such as a device driver or a service, text if you're a Mac user, to ensure that its code has a chance to run before all of the operating system security features are initialized, and it can perhaps bypass or prevent those from running, simulate results so that you can't see it. Another interesting technique is called a bootkit, and that is something which actually replaces the boot code, so it has a chance to run actually before the operating system loads. I'd actually written a bit more about this, but then I realized, well, with APT campaigns, this is not something that's optimal to use because although they are very successful in bypassing operating system security, they are also relatively easy to see and detect once you have a clean environment to work from. And, you know, if the goal of the determined adversary is long-term persistence, they're probably not going to use a bootkit technique. They'll just rely on file-based attack, the driver service. Not always, so we'll get to that in a bit. Okay. So with that in mind, there's a question of, all right, the attacker is in there. How do they exfiltrate or infiltrate? Obviously, they need to connect to other computers out on the internet or to other compromised computers within the organization at least in order to pass data on and receive instructions. On the internet connected side of things, if you're a determined adversary, It is to your benefit to use lots of domains in lots of different countries to host your command and control servers, because it makes it that much more difficult for the victim to gather information and request assistance from law enforcement all at once. Another thing that the determined adversary can do is actually hack into legitimate websites and use those. In that case, there's no fake domains that they've registered. They're simply compromised someone else's site and are using that. As far as communications go over the network, internal or external, it's often best to use common protocols. Whatever programs are commonly used, try to simulate within the organization, simulate their network traffic. It's a lot harder to find a needle in a haystack when all the needles look like pieces of straw. Of course, not all networks are going to be connected to the internet. They could be what we call air-gapped. And in those cases, the APT may run autonomously, just with whatever controls it's been told to, actions it's been told to perform, or it may periodically attempt to write data to connected media, which then can be taken out of the secure area, and that data can then be passed to the determined adversary. Okay. As I mentioned, it's important if you're a determined adversary to hide your program and hide the data that you're exfiltrating. One of the techniques that can be used is modifying the partition structure on the disk, perhaps adding a partition if there's not a maximum number of partitions already created, or to resize existing partitions, and that frees up some space for you to create your own custom partition. Or you might just take a part of the existing file system, mark it as bad, and store your code in there. These spaces usually tend to implement custom file systems in custom formats. They may use compression or additional layers of encryption to avoid being reverse engineered easily. And also point out, it doesn't even have to be a new partition or a new file. We've seen a lot of interesting uses of various databases that appear on systems such as the Windows registry to store data or attack code. Okay. Evasion is the technique that is going to be another technique that's going to be of interest to your determined adversary. They want to prevent their software from being picked apart and detected by anti-malware software. They may use packers to compress the code so that simple signature-based scanning tools can't detect them. And there's a variety of those with varying levels of complexity, ranging from simple commercial or open source projects to rolling your own. And then I can also encrypt their data or their executable code to prevent it from being easily detected. Again, varying levels of difficulty based on your own sophistication, your attack needs, and so forth. And there's also avoidance engineering. If you're aware of what security tools the defender, the victim, is using, go ahead and work against those until you've developed code that can bypass those. Okay. I did say I'd mention firmware. This is a topic that's come up recently in the press. Firmware is simply program code that resides in a chip. It's usually there to help the computer's hardware and operating system, initialize and make use of that hardware, since it's not something the computer understands as it boots up. That gives it another way to control a more advanced piece of hardware or take advantage of functionalities that aren't present in its own BIOS firmware. It's not just motherboards which have firmware in them, often called BIOS or UEFI, UV firmware. There are a lot of peripherals out there which have firmware in them, such as video cards, network cards, RAID controllers, SCSI controllers, SAS controllers, and of course storage devices even have their own microprocessors in them which run their own firmware. So those are potential vectors for an attacker. Fairly infrequent, but still I just want to mention that because we've heard a lot about that in the media recently. And as far as what languages APTs are written in, it really doesn't make a difference. It's whatever the attacker is most comfortable with. Not every highly complex APT program is going to be hand-coded in assembly. A lot of times they'll be using standard programming languages, C, C++, C#, the .NET Common Language Runtimes. They may use things which are not very popular or well-known. Simply that's where they have expertise, or perhaps to make it more difficult to reverse engineer. We've seen some interesting use of AutoLisp and the Lua framework. But even scripted languages, popular tools used by popular tools like Flash or Java, PDF files, those are vulnerable. Okay. Then for file-based deployments, when you're picking out how you're going to insert this, perhaps as an email attachment, use something that's common to the target organization. If possible, digitally signed if that's applicable. It makes it look more legitimate. Remove any metadata that might identify the origin. And I already mentioned using packers or encryptions to make it difficult to attack, reverse engineer. Okay. So with that in mind, I'm going to turn us once more over to Amelia and look at this question.
Okay, great. So our next polling question, what type of security/intrusion event are you most concerned with? And your options here are A, denial of service attacks, B, data breach, C, identity theft, D, root account compromise, or E, unauthorized devices on company networks. And so we'll give you guys just a couple seconds here. Again, just to reiterate, we cannot see who you are or how you are voting. This is strictly for research purposes for this webcast only. So please feel free to, be as honest as you want this morning. Additionally, if you are watching the recorded version, just note that you cannot participate in polling questions. That's only open during a live webcast. Okay, so looking at some of the results, I know some of you are still thinking about it and sending in your answers, but looking like an overwhelming majority of you say B, data breach, followed a little bit by identity theft, and then finishing off with unauthorized devices on company networks. So it looks like about 73% of you say data breach, which is 75 just jumped. 75% of you say data breach. About 17 are saying identity theft, and then 8% of you say unauthorized devices.
Just for those of you who may have any uranium centrifuges on your network, please choose unauthorized device on company network. Okay. Just thought I'd throw that in there. So I think we've got about all the answers, and I think we're ready to move on.
I think so.
Okay. All right. Well, thank you, everyone, for your honesty there. So I've kind of given you a quick run-through of your determined adversary, how they run a campaign, and some of the technologies used to attack you. So now we're going to move forward to how do you defend against these. There's one thing that, if you've been in the AV industry for a long time, like me, is you hear people constantly saying that traditional antivirus is dead or it's completely ineffective. And just to note, the first time I was told this was in 1990. The first polymorphic viruses appeared. Yet here we are, 25 years later. So I'd pose to you that rather than antivirus being dead, anti-malware as we call it now, simply the defensive tools have evolved in parallel with the threats that they protect you against. And I think that's probably true. So we're going to talk a bit about some of the defensive technologies using a modern layered approach to protecting against malware and how to leverage cloud. It's not a term that I'm really like, but I'll explain why. And then go to beyond anti-malware, what the complementary security technologies are. Okay. So to begin with, I'm going to go ahead and Dawn, do you want to take this, or I can proceed?
Yeah, Ari, thank you so much. Yeah, I can talk about these because these are features that are in our new product, so excited to tell everybody about.
Thank you, Dawn.
So since Ari's provided some ideas of how the bad guys plan their attacks, let's look at the life of malware, identifying these various attack vectors and how ESET has developed some new detection methods to combat this. So the first attack vector is upon a download, and ESET's vulnerability shield is an extension of our firewall and improves detection of known vulnerabilities at the network level. So by implementing detection for common vulnerabilities in SMB, RPC, and RDP protocols, the vulnerability shield protects against spreading malware, network-conducted attacks, and exploitation of vulnerabilities for which a patch has not been released or deployed. The second attack vector could occur at the time content is being processed by common applications on a PC. So ESET's exploit blocker fortifies applications on users' systems that are often exploited, such as web browsers, PDF readers, email clients, or Microsoft Office components. Basically, it monitors the behavior of processes and looks out for suspicious activities that are typical for an exploit. And when triggered, the behavior of the process is analyzed, and if it's considered suspicious, the threat may be blocked immediately on the machine, with further metadata about the attack being sent to our LiveGrid cloud system, which I'll tell you about in a second. And then related, ESET's Java exploit blocker extends the same technology, but uncovers an attempt to take advantage of a weakness or security defects in Java. The third attack vector is when files are accessed and ran. And so while signature matching provides a baseline for weeding out the good and the bad based on what is already known, ESET has been a pioneer with advanced heuristics to proactively detect malware we haven't come across before. So it detects malware based on its functionality by uncovering the way it behaves through emulation. Advanced technologies such as DNA-based scanning help to identify threats based on the code structure, resulting in higher detection rates, especially to detect thousands of malware variants where signatures are not simply created yet. The fourth attack vector is at the point that files are running. To avoid detection by solutions like ours and our competitors, malware writers tend to encrypt or obfuscate their code. So ESET's advanced memory scanner monitors the behavior of malicious processes and scans them once they decloak in the memory. This allows for effective detection of even heavily obfuscated malware. Unlike exploit blocker, this is a post-execution method, which means that there's a risk that some malicious activity could have been performed already. However, as part of the overall protection chain, this definitely is a last resort where everything else fails, and definitely could be useful. And then the fifth attack vector I wanted to talk about is the point in which malware talks back. So if malware has evaded a system's defenses up to this point, ESET's botnet protection provides another layer of network-based detection to reveal possible running threats. It searches outgoing network communications for known malicious patterns and matches the remote site against a blacklist of known malicious sites. And then detected malicious communications are blocked and the users are notified. I mentioned something earlier called our live grid, and you may or may not have heard about that. But basically, I wanted to give you a quick overview because it's central to what we do. It's basically our advanced early warning system to help detect emerging threats based on file and URL reputation, and it also improves scanning performance by the means of whitelisting. So new threat information is streamed in real time to the cloud, which enables our malware research labs to provide a timely response and consistent protection at all times. Our researchers use this information to build an accurate snapshot of the nature and scope of global threats, and so it helps us focus basically on the right targets. LiveGrid basically compares scan files to a vast database of already known objects in the cloud. When an executable file or archive is being inspected, its hashtag is compared against whitelist and blacklisted items, and if it's found on a whitelist, then it's considered clean, and it's flagged to be excluded from future scans, and that's where we see a performance enhancement. If it's on a blacklist, then various appropriate actions are taken based on the nature of the threat. And when no match is found, the file in question is scanned thoroughly, and if a sample is proven malicious, then our automated signatures are generated and immediately pushed out to customers. And so this basically allows for effective detection of emerging threats even before regular signatures are delivered to our users. And that's a standard updates, which happen several times a day. And just to note, ESET updates are very, very small and measured in terms of kilobytes. Last thing I wanted to mention on LiveGrid, so it collects anonymous data from ESET users, and it's an opt-in, so when users install our products, they would have to check to enable that feature. But ultimately, it strengthens our protection network for our entire user base. Real quick, in addition to the detection technologies to specifically catch malware, there's other layers of security are helpful in preventing or minimizing data loss, and I know on that last poll question that seemed to be a concern. So just a quick recap, encryption can be mandated or recommended in some specific vertical markets, but it's a good solution to ensure that if data is accessed by or transmitted to unauthorized personnel, it's basically useless if that cyber criminal doesn't hold the key to decrypting the data. And if you're not already using encryption, ESET can provide a free trial of our DESLock data encryption. There's 4 editions. The Pro edition includes full disk encryption, which is FIPS 140-2 validated. It's 256 AES encryption. So it's the most comprehensive protection against possible data breaches. And then the second security layer would be through a multi-factor authentication or 2FA to strengthen access to data by requiring a token in addition to a normal password when a user logs into a web app or remotely via a VPN connection. And this is important because study after study shows that employees tend to create weak or guessable passwords. They write them down and leave them in open spaces for others to find. So while security training is one method to make employees more cybersecurity aware, deploying a 2FA solution adds that additional layer of security, because even if a password is compromised, what are the chances the bad guy will also have the matching software token to gain system access? So ESET's product is called Secure Authentication. It's a simple hook into a Microsoft Management Console and the ADUC, and delivers auth-compliant tokens via mobile app on all mobile platforms or optionally via SMS. So it's a low total cost of ownership because physical tokens aren't required, and the chances of misplacing a smartphone is much lower than a key fob or a key card. So real quick, I mentioned the various new detection technologies in our products, so I wanted to kind of match those to the new next generation of solutions that we recently launched. So we basically launched the new solutions in February, and these detection technologies are equipped to basically help you catch and stop advanced and persistent threats. ESET endpoint antivirus is our entry-level business product that, in addition to the existing technologies such as device control, heuristics, HIPS, and live grid, now includes exploit blocker, advanced memory scanner, and anti-phishing detection. The ESET endpoint security is our security suite, and it has all of the technologies found in ESET endpoint antivirus, and it also includes the botnet protection and vulnerability shield. ESET file security for Microsoft Windows Server includes our live grid, our HIPS, exploit blocker, advanced memory scanner, anti-phishing, and a built-in storage scanner to easily set up on-demand scans of connected NAS devices. And all of these next-generation business products are manageable from ESET Remote Administrator, which in its latest release can not only be installed on a Windows server, but also deployed as a virtual appliance or installed on a Linux server, potentially saving Microsoft CAL fees. ESET Remote Administrator, or ERA as it's called, is accessed from a web-based console and is touch screen friendly as shown in this image. Using actionable dashboards, it gives IT staff instant situational awareness, keeping them informed of endpoint security status. Our web console has multi-platform support, so an IT admin can manage on the go, at his or her desk, or even from the smartphone or a tablet. It's also easy to deploy additional free components, such as a proxy server, which makes it easy to scale to support thousands of machines. There's also a rogue detection sensor that can also be installed to passively listen and find unmanaged nodes on the network, placing them into a static group where tasks and policies are applied automatically, and then IT can push out an agent and the endpoint client to fully secure the node, just like the others. So some key highlights. In summary, our next generation business products include these cutting edge detection technologies to help better arm you against the advanced persistent threats, and while still retaining our commitment to being the lightest and fastest endpoint solution on the market. And we kind of base that on the following concepts: that simple and ease of use contributes to better security, meaning that if a solution is simple to use, there's a greater chance that it's implemented properly and it's armed to be as effective as possible. Second, automation helps to reduce the cost and human errors and frees up IT staff to work on other projects instead of just managing security. Third, ESET of integration gives customers more choices. So regardless of how small or how large your network, regardless if you're running Windows, Linux, or Mac in a physical or a virtual environment, ESET is providing a holistic solution with standardized GUIs for familiarity and easier adoption. And then lastly, our world-class research and development for proactive anti-malware technology is critical for protecting businesses in the face of today's modern malware that Ari talked about. So that's all I have, and I'll turn it back to you, Amelia.
Okay, great. Thank you, gentlemen. Thank you, Ari. Thank you, Don. I know there was a lot of really great information in this presentation. So just as a reminder to the audience, please submit your questions through your BrightTalk portal. You can hit the question tab at the top, and we'll jump into that in just a few seconds. Before we do, we have one last polling question for the audience. At any time during the remainder of the webcast, you can feel free to request one of the following: contact from ESET Sales, a technical demo of some of the products that Don kind of touched on here, C, a business trial, which does include our remote administrator tool, D, information on becoming a reseller partner or managed service provider, or maybe E, none of the above. And like I said, feel free to respond at any time during the remainder of the webcast. And with that, I'm seeing a few questions come in, so I'm going to jump into Q&A, and I'd like to welcome back Ari and Don to the webcast. So it looks like our first question is for Dawn, and the question comes in as, is there any central management for managing endpoints that includes policies, update definitions, ERC, and that one's for Dawn.
Okay, thanks, Amelia. So the ESET Remote Administrator, otherwise known as ERA, ERA, that is our central management console, and that comes free with any business product order. So our current generation, the next generation that I mentioned, which is manageable, it's on-premise database and installation, but it's accessed from any web browser, and that will manage our new products as well as our legacy products. And we've basically separated the communications layer from the scanning. So basically you're pushing out agents to each of the endpoints to manage them, which is good, and that's where the automation comes in, because an endpoint will have its policy predefined, even if it's offline and not connected to a remote administrator. If something bad happens, it'll basically have its marching orders to know what it needs to do, kind of remediate itself, take it offline, report back that it's been fixed. So that's where some of that automation comes in based on the new architecture, but its remote administrator is what you want to look for.
Great, thank you, Dawn. I think that really answers the question there. I have a question for Ari. You mentioned that you do not like the term cloud. Can you please explain that for us?
Yeah, I'm sorry about that. I should have mentioned that before. Could we back up to the live grid slide there? But really briefly, cloud technology is a technology that you use to augment your existing tools, processes to protect against threats when it comes to anti-malware. It is not a one-shot thing to rely on, but rather something you use to make what you have better. I know there's a lot of focus on securing everything and doing everything through the cloud, and that kind of implies that without the cloud working, well, you're going to be left out in the cold, so to speak. When you are choosing security products, make sure that they are able to function independently of the cloud. At ESET, we do leverage cloud technologies, but we do that to better protect you on top of all of the advanced existing technologies that you saw. It's just a way for us to handle things more quickly, push out updates, share threat telemetry data that we get back to protect you. But it's not the sole technology. It's not the only thing to rely on, because if your connection to your cloud-based security provider is down, then your security is down otherwise. Thank you for that, Amelia.
Great. Thank you, Ari. I think those are good distinctions to make. Our next question is for Dawn, and this comes in from, it looks like maybe a customer. We have Windows desktops, but our servers are Linux. Do you have a solution to manage all of those together? And that one's for Dawn.
Yeah, Amelia. So again, it's the ESET Remote Administrator manages all of our products. So whether they're Windows endpoints, whether they're a Linux desktop solution, our OS 10 solution, whether it's Linux servers, our Android mobile products, any of those things can be managed by our remote administrator.
Okay, great. Back over to Ari. One of your competitors recently detected all files in the Windows directory as bad and quarantine them. That sounds like a pretty big failing of signature-based scanners. Can't you just scan a PC running Windows before releasing the signatures? Ari, take it away.
Okay, yeah. That's a company that likes to be very proactive about the term cloud. As far as I know, it wasn't that part of their technology that failed. A little off topic, but I'll address it. Whenever you're releasing signatures, you have to test them first not just against one PC or a dozen PCs, 100 PCs, but literally against several thousand into the tens of thousands of different configurations to make sure that things work well, don't generate false problems, introduce bugs into the product. It's tricky to do right. It's difficult to do right. That's something that, without getting too much into our secret sauce, that's something that ESET works extensively on. And it actually is an area where we actually do leverage our cloud technology basically to handle any of those issues before they become a problem. We're very big not just on proactive detection, but proactively dealing with any false positives, issues like that, before they become an issue for the computers you're adminning. Thank you.
Okay, great. Let's see. Our next question coming in looks like, we're going to ask, what is your AV solution detection ratio based on 100 infected examples? Is it above 90%? Don, do you want to take that one?
Yeah, Amelia. So I don't have all the numbers directly at my fingertips for this webcast, but I encourage the viewers to check out test results from several organizations. ESET participates regularly in testing with an organization called Virus Bulletin and then AV Comparatives, and these are global, third-party independent test houses that put our products and our competitors through a battery of tests to look at performance, and we perform very well there. So, and that information's available on their website. We link to it from various places on our website as well. But that's one of the things that we're known for is how catching the most zero-day attacks, having the fewest false positives, of course having the lightest footprint and consuming the fewest amount of resources. Even with the new generation, we've held true to that. That's sort of a core design philosophy and a goal for ESET.
Okay, thank you, Don. I think that definitely does kind of help explain that one. So the last question here we have today is for Ari. It seems like there's a lot of information available about companies on their websites, like job listings from their employees' use of social media, press releases from partners, etc. How do we get rid of or prevent this information from being used against us?
That is a great question. In short, you can't. You can just reduce the amount of information that's available. In the case of job descriptions, consider removing specific product names and technologies, product names and version numbers. So maybe instead of saying Microsoft Windows XP, you just say Microsoft Windows Desktop Operating Systems. Instead of saying you're using a particular security product, we're using vendor X, mention products such as vendor X, Y, and Z. That makes it a lot more difficult for an adversary to gain intelligence about your organization. LinkedIn profiles, obviously, that's an area because that's something for you folks to work out with your HR. As far as web forums go, make sure employees don't use their name or mention the company. Information that can lead back to an attacker gaining information about your internal systems and technologies. Okay.
Okay, great. Well, it looks like there's one other question about whether they can get a free trial of the central management or the endpoint or both. Absolutely, that is definitely available on our website. If you go to eset.com, you can sign up for a free business trial. You can also request one through the polling question, the last polling question. So just hit that free business trial option there. So with that, I think we conclude our Q&A session. If there's any questions we did not get to, we will try and answer them to you individually. So that concludes our webcast today. I would like to thank Dawn and Ari for their time today, and I'd like to thank you all for participating in today's webcast. We sincerely hope you found it valuable. You can rate this webcast, or you can share it through your social media channels in your Bright Talk window. For more information on ESET endpoint security products, please go to ESET, that's ESET.com. Thank you, and that concludes our webcast.